Next up we have Dudley Stewart. Dudley is Managing Director of Microelectricity Generation Association and a founding member of the Microelectricity Generation Association. Dudley has a demonstrated history of working in renewables and the environment industry. In the mid-70s, he founded one of the first ever dedicated renewable energy companies in Ireland and drove the development of modern wind turbine blade design and governing systems. So you're very welcome, Dudley, and we look forward to hearing from you.
Thank you all for having me here. So a quick reminder of the key facts. Ireland is a high-tech agriculture economy, and it's highly dependent on imported energy from far-off places. And Ireland's electricity system ranks amongst the most dependable and reliable. In fact, the quality of our electricity system is at the heart of our successful Irish economy. In COVID-19 and climate change are the big issues of our times. Both have been shown to be interlinked. Nonetheless, right now, Europe has set the very challenging objective of reaching near zero carbon economy by 2050. The number one challenge has been a huge success. That is the large-scale harvesting of energy from sun directly to solar PV or indirectly to wind, water and ocean. The challenge for citizens and digital power now today is to direct, shape and convert this energy and to improve its use, efficient use, and to get to where it's needed, when it's needed. This means essentially squeezing power through the complex twists and turns of the labyrinth, which is the typical urban electricity and gas distribution system. The EU mission is to move progressively towards as many energy cities as possible. Positive energy cities, starting with positive energy blocks and pushing this out to districts. Positive energy systems and strong microgrids will be the energy stabilizers in the evolving energy transition. And they'll help us when we have communications breakdowns too. Clearly, the old siloed, centralized energy system is quite naturally falling away. We are seeing the emergence of an increasingly more complex and intertwined energy system. There are signs of emerging energy anarchy already in some parts of the USA. This is dangerous. Citizens and digital power offer the means, however, of regulating and streamlining this new energy system and keeping it safe. I hope here to highlight our view of the challenges ahead in achieving of the near zero carbon Europe. We have come to the point now where digital technology is ready and acceptable as the key way forward. Digital power in the informed hands of citizens as prosumers is the other key. Another new advance is the emergence of the EU frontline citizen energy community. That's the citizen energy community as the key digital tech enabler, working with the electricity system to restore and maintain stability throughout the crucial years of the energy transition ahead. Again, over the past decade, the key emphasis has been on two significant movements. These days, both are driven mostly by large corporations and government, mostly, I say. Conquest of renewable energy harvesting, and again, the digital technology innovation. Renewable energy harvesting has been focused on achieving critical economies of scale with digital technology breakthroughs in design, materials, testing, reliability, lifespan, and scale. Rising levels of renewable energy penetration have created increasing complexity to the grid, rising intermittency and predictability issues, the sheer volume of new power generation installations, varying in size, location, design, and diversity in source, differing in ownership and control models. All of these are combining to cause serious grid stability and capacity issues. The pressures to increase installing renewables in the absence of appropriate change to the grid and the way it works will cause system operators to pause grid connections of clean energy sources. Missing this digital moment would upset national plans or put at risk the grid itself. Meanwhile, the digital technology revolution is heralding breakthroughs in scale and innovation. This is driving sophistication in the automation of buildings and residential dwelling. Cloud-based control systems can already simultaneously switch on and off vast numbers of loads. These innovations and the scale of deployment bring considerably more challenges to the power system stability. Great things are possible through cloud technology, but a greater understanding of grid stability requirements is needed as social media giants move towards this space. The new EU energy communities offer new ways of moderating and regulating the grid, forming well-organised and resourced EU-style energy communities as local enterprises is challenging, but serious resources from the EU are now coming through to assist through the Green New Deal. The experience in Europe is that such communities can be the moderators and contributors in favour of grid stability, and also providers of the needed growth in flexibility. This is the new digital technology opportunity and challenge of our times, and we need to harness the momentum towards solutions that are mutually beneficial for both users and the operators. Clear examples of these new possibilities can be evidenced from the Dublin-located Tala Smart Grid Testbed. Initiated by South Dublin County Council with MEGA in 2009, this living lab has shown how digital communication technologies can empower local communities, acting as smart grid cells, stabilising the grid and allowing ever-increasing levels of diverse distributed clean energy solutions through disturbance-neutral community grids. Huge efforts are focused on the new power system architecture. Whatever the solution, the result must be highly robust, dependable, quality assured, resilient in adverse conditions. Basically, a new smart grid system must do what it's meant to do. It must enable near zero carbon electricity. It must do this while always preventing harm to the system. Electricity grids are fast becoming digitally smarter. It is widely agreed that the new resilient smart grid must be made up of a mesh of intertwined microgrid systems. Microgrids are easier to manage, involve citizens as organised prosumer communities, and invest heavily in energy storage and flexibility. Flexibility to adapt consumption as much as possible to available power, power from generators, batteries alike, and also from motor vehicles, as said earlier. The benefits of a grid based on intermesh microgrids would be huge. Production could be contained, stored, converted, or consumed within the microgrid in line with the needs of other parts of the grid to export or import. Severity of impact from cyber attacks and viral rolling blackouts could be significantly reduced by managing islanding of selected microgrids and more. Migrating to the more ideal intermesh microgrid system on time to stay in front of adverse developments is a clear need of current times. The current quest is there a way of using the benefits of intermeshed microgrids in a more gradual and reward-driven way to stimulate the speed up of this migration? In Ireland, Empower is currently developing candidate microgrids made of willing prosumers within the physical remit of future microgrid boundaries. Following the IEA award in 2019, these have become known globally as community grids. Empower in Ireland is actively developing community grids. The natural boundary of a community grid is the medium voltage substation. Empower works with prosumers locally inside these boundaries, enabling through a regulated system a set of digital technologies willing prosumers to work together to achieve local disturbance neutrality. Disturbance neutrality is assured by a combination of digital technology and compliance with power quality rules regulated by contract. Empower has developed a full system to implement, operate and maintain community grids, which are effectively smart grid cells. Empower is developing the first disturbance-neutral energy communities and is progressing with the process to become the first licensed community system operator. Such communities respond autonomously with a minimal or no interaction with the distribution system operator to disturbances from production, storage, and flexibility created by energy prosumers. Moving on now to the anatomy of a community grid cell. The backbone of a community grid is a network of SLUs. These are 1 second interval prosumer smart meter controls, very fast. These are linked by high redundancy machine-to-machine communications networks, linked to the local server at the local energy hub and supported by the Exchange control and trading system. With disturbance neutrality assured by the community grid stabilizer, equipped for ultra-fast uptake through ultracapacitors and emergency power dissipators. Ireland's first EU lighthouse smart city is located in Limerick. It's deploying community grid systems to form EU-style positive energy districts. Digital technology and energy community systems developed first on Tallaght Smart Grid testbed are being refined and embedded in the heart of Limerick City. This is together with Dublin, the Aran Islands, Trondheim and other EU cities. The new energy community-based digital technology power of community grids is underway with positive engagement from both energy regulator and the electricity system. Community grids are one of the new ways forward through the new enlightened power of both communities and digital technology. How do I play that vid? Can I play the video?
Today we are very excited because we are launching in Limerick the first European Lighthouse Smart City project called City Exchange. With this project, we are aiming to develop solutions for the creation of positive energy cities. A positive energy city is, in fact, a city that generates more energy than it actually consumes. We are going to start at a block level with 5 buildings and then try to replicate this across additional blocks.
The Georgian neighbourhood, which is where the pilot programme is focused, was built 250 years ago on an intelligent grid system. So we aim to repurpose that logic of the Georgian neighbourhood into a new type of energy system, a community energy grid where collectively people can share and exchange energy between buildings and between buildings and vehicles.
What attracts us to the Positive City Exchange project is that decarbonisation in an urban and a city sector is going to be a real challenge if we're going to meet our climate change goals. So for us, we're going to learn the impact of deploying those technologies and what do we need to be doing to facilitate that.
Today is indicative of what Limerick has been doing for the last number of years. It has been leading out on innovation, it has been disrupting the market. So this is bringing how do you energise and make maximum efficiencies in old buildings. And if we crack it here in Limerick for Europe, and for the globe, I think we'll be on a winner, and this is where Limerick is leading off.
Thank you very much. So, over to questions. I'm in your hands.
Dudley Stewart, Managing Director, Microelectricity Generation Association. Thank you very much.